Alright, number 22. So you have x plus 3 squared minus 49 equals 0, and you're trying to solve for x. Now, one of the biggest common mistakes is kids will think, oh, I need to write this out like x plus 3 times x plus 3 and FOIL. But I don't want you to do that, guys. We don't want to expand anything and make it into a polynomial. I want to condense it and get x by itself. So don't do that and try to FOIL it or multiply it out. The best thing in this case I want you to do is get x by itself. So the easiest way to do that, the first step, is to move over this 49. So I'm going to add 49 to both sides. So on the left, you just get x plus 3 squared equals positive 49. Now I want to get this x, get rid of this x, but the problem is now it is attached to the 3. So I can't subtract anything yet because it's attached to the 3 and the whole thing is being squared. So I need to get rid of this squared function. So I'm going to take the square root of both sides. And this square root and this square is going to cancel. So I get x plus 3 equals, and now the square root of 49 is plus or minus 7. So the next thing I'm going to do is just to get x by itself, I'm going to subtract 3 and then subtract 3. So you get x equals, I have positive 7 minus 3, which is 4. So my first answer is 4. And then I have negative 7 minus 3 is negative 10. So x equals 4, x equals negative 10. That's it for that one. Alright, the same thing for the next one. I'm going to now do number 24. So I have 2x plus 3 squared minus x minus 1 squared. The same thing here. We don't want it. We're trying to get x by itself, so we don't want to expand it and FOIL. That's not what I want to do. It's kind of hard to see. It's a little bit in disguise, but this is actually a dots product. A dots problem, not product. A dots problem, a difference of two squares. The reason why I know that is because, remember, you have something squared minus a number that I can take the square root of, or it's a number squared minus a number squared. I have that negative in the middle that kind of tells me right here that it's a product of two squares. So remember, I always draw my two big factor bubbles. One's going to be plus, one's going to be minus. Sorry, I didn't mean to write that, just a scribble. Now, remember, the example I always tell my kids is think of x squared minus 25. The answer to that would be x plus 5, x minus 5. What I did is I said, what times what gives me x squared? And it was x. X times x gives me x squared. So I'm going to look over here, and I'm going to ask, what times what gives me this function? What times what gives me this whole function, 2x squared, 2x plus 3 squared? So the answer is 2x plus 3. Because if I have 2x plus 3 times 2x plus 3, I'm going to get 2x plus 3 squared. Same thing here, like I got x times x, I got x squared. So over here, now what I'm going to do is, now I have this guy. What times what gives me x minus 1 squared? Break it up, just x minus 1, x minus 1. But you have to be careful here because we have a negative, so I need to put this guy in parentheses, because I'm going to have to distribute. Here it doesn't matter because it's positive, but over here I do because it's negative. Now I'm going to smush each individual factor bubble. So here I have, just focus on this guy, I have 2x plus x gives me 3x, and 3 minus 1 is 2. On this side, I'm going to distribute this negative first. That's what my math spidey senses are telling me to do. So I have 2x plus 3 minus x plus 1. So smush, I have 2x minus x gives me x, and then 3 plus 1 is 4. So this is all equal to 0. And now I'm just going to solve. Each individual factor bubble is going to now be equal to 0. So first step, subtract 2. You get 3x equals negative 2. Divide by 3, so x equals negative 2/3. That's my first solution. Now for my second solution, I'm going to subtract 4 from both sides, so I get x equals negative 4. That's my second solution. Alright, sorry, I kind of switched over my slide, kind of funky. Last one is number 26 that I want to do from the factoring section. This one's a little weird because here there's no numbers, it's all letters. But remember, our goal is we want to get x by itself, solve for x. So I'm going to set do your same process you always do, set each factor bubble equal to 0. X plus b equals 0, x minus h equals 0. Now, if this was a number, just pretend b and h are numbers, and x is your only variable. If I want to get x by itself, if that was like x plus 3 equals 0, I would move the 3 over. Just making this up, right? That's what you would do. Same thing here. Just treat b as a number. So I'm going to move b over, so you get x equals negative b. And that's your final answer for that guy. Here for this one, just treat h as a number. So I'm going to add h to both sides, so you get x equals positive h. And that's your final answer.